All right, so here's the story so far. Daniel is traveling west across the river so that his velocity relative to the shore is 7.141 meters per second west. We're still continuing with the same story as we started in parts A and B. And that means that he's got a VBS that's written in green here going to the west. And we got that as a result of adding VBW plus VWS tip to tail. That's the story so far. We're going to call west positive and south positive just for argument's sake here. And we haven't stated a question yet. What I would like to figure out is did we figure this out yet? Yeah, how long it takes for Daniel to cross the river. How long, and when I say how long, I don't mean a length, I mean a length of time. How long will it take for Daniel to cross the river? Now, there's two ways of thinking about two-dimensional motion. There's the x part of the motion, and there's the y part of the motion, okay? Now, what you don't know here is how wide the river is, and that's going to impact the answer greatly, okay? So I'm going to give you that as a piece of information. I'm going to give it to you as a nice round number. I'm going to say that the width of this river, we're going to call it, this is a double-ended arrow here, delta dx, no, a nice round number. The displacement in the x direction, if I should cross this river, will end up being 37.21 meters. Nice round number. Okay? Nice round number. 37.21 meters. Yes, sir?
Isn't the velocity of the water relative to the shore 7 meters per second?
No, we said that the velocity of the... Did we say that? Oh, you're right. The velocity of the water relative to the shore was 7 meters per second. You're right. We did. I shouldn't change the values as we move along here. So the velocity of the water relative to the shore is 7 meters per second. My mistake. Shh. Okay, so we want to figure out how long it takes for him to get across. I know the displacement in the x direction. What's the velocity in the x direction? Can you pick that out of these values? Which of these velocities? Velocity of the boat relative to the water, velocity of the boat relative to the shore, or velocity of water relative to the shore is the velocity of the boat moving xward in the x direction. What's that? It is VBS. Velocity of the boat relative to the shore tells us its velocity in the x direction. In other words, how fast is it sort of translating westward across this river? This is what we're looking for here. So if I'm talking about delta D in the x direction, ladies, I don't want to talk above you. If I want to talk about the delta D in the x direction, 37.21 meters, I'm going to need to discuss the velocity, or the average velocity in the x direction, which in this case is VBS, or 7.141 meters per second, if I want to find the amount of time that it takes to traverse that. Now, there's no acceleration here. Acceleration is equal to 0, so I'm not going to even talk about it. What's the equation that involves V average, delta D, and delta T?
V average x right there.
Yeah, V average in the x direction. Yeah, delta D over delta T. So I could say V average in the x direction at least is equal to delta D in the x direction over delta T. So my speed westerly or my velocity rather westerly, is equal to my displacement westerly divided by my time. That sort of makes sense. And if I want to get delta T all by itself, it looks a little something like this. Delta dx over V average x. And if I sub in my values, delta dx, 37.21 meters divided by 7.141 meters per second. It gives me a nice round value of 7.442 seconds. Or if we're going to two significant digits, that's approximately 7.4 seconds. So it takes about 7.4 seconds to get across this river. That's a pretty fast boat, but it's a pretty fast rower. So, you know, he's super, right? Yeah, Daniel. He is a maniac. Oh, did I mess that up? I did mess that up.
I'm done.
No, it's okay. The delta t was 5.211 seconds. I did answer the next question. 5.211 seconds. Did somebody else try to answer the next question and predict what I'm going to do next? It is. Yeah. 5.211 seconds, rather. Or approximately 5.2 seconds. I can't believe I did that again. So embarrassing. All right, part D. Let's try part D. Woohoo!
What happened? What?
It took him 5.2 seconds to get across this river. Ooh la la.
Honestly, do you have caffeine this morning?
Me?
Yeah, because
I know. 3 mistakes in one day? Holy moly.
Did you make any mistakes last period?
No.
Are you sure? Not sure. What if everything you're doing is right now and everything last period is wrong?
No. Okay, here's the what if. What if? What if Daniel... Guys, we're building a tale of rowing here. I need to focus. What if Daniel simply points his boat west and rows? There's E parts. But D and E are fairly short ones. What if Daniel simply points his boat west and rows? And we said that Daniel, once upon a time, what was Daniel capable of rowing his boat?
10 meters per second.
Okay. So velocity of boat with respect to the water is 10 meters per second. But instead of saying boat with respect to the water, I could say, isn't that the same as saying the average velocity in the x direction? It's new. It's the new x value, the new x velocity. But if I just sort of point my boat west and just let her rip, it's going to be VBW if I decide to point my boat this way. Okay? That's going to be the average velocity in the x direction. So that's going to be the velocity that contributes to me crossing this river. The average in the x direction. And we're saying that Daniel is so super, he can row at 10 meters per second west, or positive 10 meters per second. What's the displacement again in the x direction? 37.21. Yeah, delta D in the x direction, or the width of the river, in other words, is 37.21 meters. What's the formula for calculating how long it takes for Daniel to cross this river now? Is it any different?
Delta D over
Oh my god.
Yeah, we can say delta T, we already rearranged it once. Delta T is equal to delta dx over V average in the x direction. We already did that rearrangement one time. We don't have to do it again. It's right there for us. Is equal to 37.21 meters over 10.0 meters per second, or, divide by 10, this is an easy one, 3.721 seconds. Or we will round it off to two significant digits. We could say it's approximately 3.7 seconds. So which is better if you want to just get across the river? Forget about getting to the dock on the other side of the river. Do you want to go straight west and point yourself west, or do you want to sort of point yourself slightly upstream to cross this river if you want to go fastest across, or if you want to make your time a minimum for crossing the river? Yep. Point west and go west, and sort of go at an angle. It's still going south. So if you want to get across this river in the minimum amount of time, point yourself straight west and just accept that you're going to get washed downstream. But if you want to go across this river and actually land on a dock that's due west, you're going to have to point yourself upstream and accept the fact that it's going to take a couple seconds longer to get there.
Okay. 2 seconds.
Well, hey, but that's only for Super Daniel, right? For the rest of us, maybe a little longer. Yeah. Yeah.
What's this beside the V average x? What's equal to 10 meters per second?
Oh, that's how fast the boat's capable of going in the x direction if the boat's pointed
it
straight
should
west.
be like another equal side down.
Yeah, yeah. I was just trying to fit it into this corner of the page. Okay, there is a part E here. Let's finish this off, okay? Part E. assuming it takes 3.7 seconds to cross the river. I'm going to take this sheet away, slide it up a little bit. For the same river, so here's the river again. Assuming that it takes, so I should make this part E. Assuming that it does take 3.7 seconds for a boat starting on this shore to go across, and you know if the river is trying to wash it downstream, the boat's really going to take a path that kind of is like that. Right? It's going to get washed downstream for every second that goes by while it tries to go westwards. So it's kind of going to get washed downstream and land here-ish. It's going to take 3.7 seconds for this thing to get across the river. I could say more accurately 3.721 seconds to get across the river. I'd like to know how far it's going to get washed downstream from where it started. It's got 3.721 seconds to have it happen, to have it get washed downstream. But I want to know how far. And when I talk about how far, I'm saying delta D in the y direction. If I'm saying displacement in the y direction, what velocity do you suppose is going to achieve that displacement in the y direction? What direction of v? Yeah, the y velocity. And in this case, if we go back to our original diagram, which of these vectors, this, is going to contribute to my displacement in the y direction? Yeah?
VWS.
VWS, yeah. So VWS, for this little story, VWS is, for our purposes, the average velocity in the y direction if I just point my boat west and let the current take me south while I try to kind of get westerly. V average in the y direction in the story that we've been using up to this point, what was the velocity of this river again? 7 meters per second. Okay. I want to figure out what displacement in the y direction is if I know the average velocity in the y direction and I know how many seconds are going to go by for this motion to occur. What's the equation I should use for delta D in the y direction? What has V, D, and T in it? Yeah, delta displacement over time, right? So I could say V average in the y direction is equal to delta D in the y direction divided by delta T, or getting delta D in the y direction by itself, delta dy is equal to V average in the y direction times delta T. Really, these are vectors, but I'm dropping out the vector signs for now. V average in the y direction, 7.0 meters per second times 3.721 seconds. It's going to be somewhere between 21 and 28, closer to 28. What's 7 times 3.721? Somebody with a calculator. 3 times 7.21. 3.721 times 7. 20.63? Is that right?
Yeah, it's
0.47. That sounds closer. 26.047 meters. All right, so what we're saying is if you just point your boat west, and the only velocity that you're experiencing really in the y direction is the velocity that's translating you south, the river, you're going to go downstream 26.047 meters while you travel the 32 point however many meters, or 37.21 meters across the stream. So approximately 26 meters south.